Now we are going to implement an example with the help of KNN machine learning algorithm, and this is the data set in which we are working on, user data. It is having user ID, gender, age, estimated salary, and then there is a column purchase. That means he or she can actually purchase a SUV or not on the basis of these columns. Now firstly what I have done is I have imported several machine learning libraries which are required in this code. Then you can import the folder or the file if you're using the Google Colab here, and simply give here df equals to pd.read csv and then give the path. Like you can click here, copy the path from here and paste it here. And then I have used df.head, so that will display me the first 5 columns which are there of the user ID, gender, age, estimated salary and purchased. Next here you can see that whether a person can buy a SUV or not, is it really depending upon the user ID? No. Is it depending upon the gender, that whether he or she can buy or not? No. Is it dependent on age? Yes, it is dependent, because with respect to age and the salary is actually both the columns which are depending, that whether he or she can buy a SUV or not. So these 2 columns are not required. So we have used the ilog function to remove these 2 columns, and in X what we have stored, that our trained set we have stored second and third columns, that is the age and estimated salary, and 4 we have stored in Y, that will be our giving the result set of the prediction. So now as I execute this particular set, that means this particular set is divided into 2 sets. Next, from the sklearn model selection, what I have done is import train test split, which we do for all the models of machine learning training, xtrain, xtest, ytrain and ytest. Using the train test split, we have split it into X and Y. That means this is the X set of data, age and the salary, and the purchased or not is the Y set. Giving the test size 0.25, that means 25% of data is used for testing and rest data is used for training, and random state equals to 0. Next, what we have done is from sklearn preprocessing import standard scaler. Now why we have used this standard scaler, you can see here in this particular data, the age might be in a difference of 1 or 2 number, but salary has a huge difference. So to standardize that, to scale that particular data, we have used the standard scaler from sklearn library, and we have trained and test set of data using that. Next, here you can see that this is the new thing. From sklearn neighbors, import sklearn or KNN classifier. And that I have used a KNN classifier that is having neighbors. The value of neighbors is given. If you do not give any value, then it will take by default value. And then here I have passed several parameters. So let us go to the official documentation. Here you can see sklearn.neighbors KNN classifier implementing the KNeighbors vote. Now only the neighbors, you can see here it is giving 5. If you are not giving any value, then by default it takes the value as 5. And here are the rest of the parameters which are there. P is actually the power parameter for Minkowski matrix, and when P equals to 1, this is equivalent to the Manhattan distance. Now I will show you what distances are there. So these are some matrix initiated real value vectors. Euclidean distance, which we discussed in our previous video. Manhattan distance is also there, and here you can see the Minkowski distance, that is argument is P, and this is how it is calculated. So that thing I have only written here, that the metric is Minkowski. I want to classify that in the basis or distance calculation on the basis of Minkowski, and the argument I passed at 2. And then I have fit my model KNN, which I have given in the name of variable. So you can see that this is the respective output. Next, we want to predict the set of values. So for that, what we do, simply use the .predict function and store it in a variable. So that's what I have done here. Here you can see that there are several predictions which are made, that is of Y predict. Next, what we have done is, lastly what we need to do to test the accuracy of the result, that what is the accuracy, by creating actually a confusion matrix. So that also we have imported from sklearn.matrices, and there we have confusion matrix that gives us the value that how many predictions are correct and how many predictions are wrong. So here you can see that it shows me a matrix of 64, 4, 3 and 29. So what do this means? Here we can see that 64 plus 29 is equals to 93. That means there are 93 correct prediction, and 3 and 4, that means 7 are incorrect prediction. Whereas in logistic regression, there were 11 incorrect prediction. So now we can say that the performance of our model is improved by using the KNN. So this is all about the example of the KNN, or we can say the k-nearest neighbor algorithm for machine learning. And we have also done another example that is in our website of the iris dataset, but it is a different dataset, so I use this example for explaining you.